Okay, today I would like to start with a recap of the last video. This is the Math 120 videos. I think on the last video I touched on um, mean, standard deviation. I hadn't started on the standard deviation yet. So I will start today with standard deviation for both a data-driven table like test scores, and then we'll do a frequency distribution. So let's go ahead and I'll just make up a problem with some like ages in the classroom. Let's say we have 6 people in the classroom and their ages, and I'll just label this ages in class. And we say we've got an 18-year-old, or 2 18-year-olds, a 19-year-old, a 21-year-old, 25-year-old, and a 36-year-old. 6 people in class. So n is equal to 6 because there's 6 people in the class. And I always tell students, whenever you see n, that is usually how many people, or what makes up the population for your data. So in this case, there's 6 students. So n is equal to 6. I'm not going to go through the range, mid-range, and all that. I went through that in the last video, and that's just basic arithmetic. So I'm going to kind of hold off on that. I'm going to focus these 2 videos on the mean and the standard deviation, and what is the mean and the standard deviation. The first thing you have to get is the mean, and we've already talked about that. The mean is equal to the summation of x over n, and add all these up. Of course, I haven't done that, so we'll just do it by hand. 11, 12, or there's a 10. Anytime you get a 10, it's easy. So there's 10, 15, 21, 29, and 37. And then your 3 here. So there's 3 and 3 is 9, 10, 11, 12, 13, 14, 15, 16. Looks like about 167. I hope that math is correct. And then we divide by 6. So 167 divided by 6 is going to be 2, and that's going to be 12, and then 47, and 6 will go into 47. I'm going to go ahead and say 8 times. It's less than 8. It's 7, and I don't know, 7.7 repeating or something like that. I'm not going to worry about that. We're just going to say, for all practical purposes, we're close to 28. And I did that because this is 47. 6 times 8 is 48. So I'm using this as a round number to kind of keep this simple. So the mean, the average mean in this class is 28. And what that means is that if we had a curve, bell curve, and you had a center, that center would be 28 because that's the mean. Okay? Now, to find the standard deviation by hand, first of all, you have to realize what the standard deviation is. The standard deviation, or S, omega, or sigma, or S, is equal to the summation of x minus x bar, quantity squared, over n minus 1. Now that's the formula or the equation for your standard deviation. Now, most teachers like to show you how to do it by hand first, and then we use technology to kind of speed up the process. And I'm one of those teachers. So we'll just get a column here, and this will be x, and that'll be our numbers: 18, 18, 19, 21, 25, and 36. and we'll just make 3 or 4 columns across here. And this is going to be x minus x bar. Well, we know x bar is equal to 28. And I'm going to make things simple, I'm going to use my handy dandy phone calculator if I can get on it. And we can subtract these. Everybody knows 18 minus 28 is negative 10. 18 minus 28 is negative 10, but it does help you to actually speed up the process by using a calculator, so I'm not going to deprive you of that. If you want to use it, that's fine. I just don't like students using calculator to take the square root of 25. I mean, that's ridiculous. So 18 minus 28 is negative 10. Negative 10, and that should be negative 11. I don't like 28. Let's see, be 19 minus 28 and negative 9, and 21. That's going to be 28 minus, or 21 minus 28 is negative 7, and keep going. 25 minus 28, negative 3, and 36 minus 28. 36 minus 28 is equal to 8. Okay, so there's your x minus x bar. Now, of course, you got an x minus x bar, and then you got to square it. So take each one of these and square it. So x minus x bar, quantity squared, and that's going to give you 100, 100, 81, 49, 9, and 64. Notice that all of these are plus. Why? Because you're squaring. Anything squared is going to be plus, and it just works out nice that way. So 281 plus 49 plus, or 281 plus 58 plus 64. 281 plus 58 plus 64. I get 403. And that right there is our numerator for this. So S is equal to x, variance, that's square root, sorry about that. S is equal to the square root of 403 over n minus 1 will be 5. And remember, n minus 1, n is 6. I usually teach this class and I get, where'd 5 come from? Well, 6 minus 1 is 5. You can't forget that n is equal to 6 in this problem. So do the math, and when you get let me mention this. When you get 403 over 5, that is actually the variance. Now there's going to be some questions that ask you for the variance. Let me just make a note right there. 403 over 5 is your variance. Not used very much. It's used more in the second statistics course that we used to teach, but for this problem, I just thought I would make that note so you could make it in your notes. And 403 divided by 5 comes out to be 81, or 80.6. So our variance is 80.6. And square root of the variance is the standard deviation. So if I take the square root, then I get the standard deviation. And the square root of 80.6 is, oh my, I gotta use my scientific calculator. And that's going to be raised to the 0.5 power. I get 8.97, which is pretty much 9, or 8.977, da da da. Okay, so S is equal to 9. Now what that means is, go back to our original problem. here is our mean, and I'm going to add 2 standard deviations to the right, and the reason you add is because addition is to the right, and I'm going to subtract 2 standard deviations on the left because left is negative. So 28 plus 9 is 37, and 37 plus 9 is 46. 28 minus 9 is 19. I'll always have to check my subtraction, and 19 minus 9 is 10. Now let me again make a note. I used round numbers here. This is 27 or 27.7. The reason I'm using a whole number here is because of explanation purposes. You can deal with the decimals in your calculator. Always remember that to read the directions about rounding. But the only reason I'm using whole numbers here is because it's easier for me to show than write a bunch of decimals on the video. Now, if you look for the empirical rule in your book, and I don't know if I spell it right or not, but I think it's either with an H or without an H. Empirical rule. I'll have to look it up. It's one of those two. I think it's this one. The empirical rule gives you percentages within 2 standard deviations, and look it up in your book. It's in section 3.3, I believe, and 95% of your population is going to fall within 2 standard deviations. So you know that, let me use a different color marker here. You know, based on this data, that in your classroom, most of your classrooms, based on this data, that 95% is going to fall between the ages of 10 and 46. And that's what that means. That's why you have standard deviation. I like to explain standard deviation as kind of a estimate. If I tell you that I can paint your bedroom for $200 plus or minus $100. Okay, that's kind of a far-fetched estimate. But what that means is I have a contingency of $100. In other words, if I go in there and the paint does real well and your walls are real smooth and everything's nice and hunky-dory, I can probably go on the low side with $100. But if things are not as hunky-dory as it can be, and I go in there and got all kind of junk stuck on the wall and tape and all this other stuff, and I have to do a little bit extra work, then it's going to be at the high end of 300. 200, and I added 100 on this side, and I subtracted 100. So with standard deviation, you're going one standard deviation, and then you're going another standard deviation. So I would add 100 more. That would be 400 if I was doing standard deviation. And this way would be negative 100 minus 200. 100 minus 100 would be 0. So if I changed my terminology and said that this estimate has turned to standard deviation, then this is your mean, and this is your standard deviation. So you're going in increments of 100 to the right, adding, and you're subtracting with increments of 100 to the left. And you know, look at it as an estimate, or look at it as plus or minus 2 standard deviations. That is basically what a standard deviation gives us in probability and statistics, or statistics. So just to recap, the first thing you do is get your data organized. Find the mean first. Okay? Once you find the mean, then you need to find the standard deviation. And this is the formula for standard deviation, for the standard deviation. And this is by hand, and you get this number, and that number divided by 5 and the square root gives you the standard deviation. And note that if you just didn't do the square root and did this, then you would get the variance and then take the square root of that number, and that's what I did right here with the dotted. When you take the square root of this sentence right here, you get the standard deviation. The square root of the variance is standard deviation, and the square root of 80.6 is 8.977, which for instructional purposes I rounded to 9 to make it simple. Okay, so I hope that helps you at least with an introduction to standard deviation and what is standard deviation. Standard deviation works with the mean to give you the parameters or the 95% interval of your population. That's that. Now, with a frequency distribution, it's a little bit different. I think last video I did a frequency distribution for you, and I found the mean, and I'm trying to find that right now. I think it's this one. Yeah, I'm looking for it right now. There's the midpoint, and it's in here somewhere. Range, mean. Well, I thought I had it. Okay, here it is. I think this is it. Yeah, that's it. Now this is how you find the mean of a frequency distribution. Here we have a frequency distribution with IQ scores and the number of people that made this score. And you want to find the mean IQ score. In other words, what's the average based on this population, right here. What is the mean? And we did the math. Of course, you can't use these right here because these are classes. You've got an area. Okay, this is an area. 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 This is a range. This is a class. You can't plot a class, and you can't calculate a class because there's 10 numbers in here. You can't. You've got to get this down to a single number so you can calculate, so you can graph it, whatever the case may be. So the IQ scores, the classes, are not going to help us very much. That's why I kind of marked through that. We've got to come up with a number using the classes that will give us something calculatable or something we can calculate. I don't even know if calculatable is a word. Something we can calculate with our frequency or our head count, whichever one you want to call it. I hate to use the word frequency because that makes you sound like some kind of radio transmission or something. This is basically the head count. This is the midpoint. The midpoint is that number that I need from this. This pretty much is useless as far as calculating, as far as graphing. So this is the number that we use to make up for this being so broad. So, and we said that the mean of a frequency distribution is the summation of f times x, head count, times midpoint. And we add those up, or we multiply them together, then add the number up, and that'll give us a number. I'll take these numbers, add them together. multiply this number times this number, this number times this number, this number times this number, and then add all those up. That will give you this numerator. And the summation of f would be this number right here. I think it's 35 plus 33. That comes out to be what, 68? 68 plus 10 is 78. So our summation of f is equal to 78. You can also say that's n. There's 78 people that took the test. Alright, so we've got that number, which is right here. And then the summation of f times x. Well, here's f, here's x. So we need to kind of have another, I hate to do this, but a f times x column right here. And we'll do that right quick. And again, it's important that you understand how to do this by hand, because actually, unless you really put it out there on a spreadsheet, that's the only way you're going to be able to do it, a spreadsheet, or doing it by hand, either on a calculator or doing it by hand with this. So with the pen and paper. So 2 times 59.5 is 119. 33 plus I think that's 69.5. 69.5. 102.5. 99.5. No, 59, 79.5. Sorry, 79.5 times 35. Ooh, that's a big number. 2782. And then 119.5 times 7. 836. Yes, I'm not using the 837. I'm not using the decimals again because of showing you how to do this. You just need to know how to do the math. The decimals you can do on your calculator. And then this turns out to be 140. And now we add those up. So 140 plus 837 plus 2782 plus 103 plus 119. And I get 3981. 3981. So that is the numerator. So x bar for frequency distribution is equal to 3981 divided by, and summation of f would be 78 divided by 78, and that comes out to be 51.04 or 51. So the average, based on this data, the average is going to be somewhere around 51, which is going to be somewhere in this area right here. And that looks a little bit, you might have to check my math because I think I might have an error in there because it looks a little low. It should be right in here. So you need to check that right quick. Anyway, let's say that the average is 51. Then of course we draw our graph, and there's our 51 right there, and then we'll find our standard deviation. Now the standard deviation formula is pretty rough. It looks real intimidating, and it's not that big of a deal. The standard deviation for a frequency distribution is equal to the square root of n times f times x squared minus f times x, quantity squared, over n times n minus 1. Now, it's pretty intimidating, but what you need is you've already got f and you already got x. So all you need is, and you already got n, so all you got to do is plug and chuck. You do need f times x squared. You haven't done that yet. You have done f times x, and f times x, like I said, is going to be, summation, sorry, summation here, and summation here. You've already got that. That's 3981, and then you're going to square it. So make sure that you do your, and we can go to this problem right here, and we could add another column and call it f times x squared. Now, I'm not going to do a column with x squared because you can do that. That's 44. I mean, that's 4. That's going to be a big number. That's going to be a big number. That's 49, and that's 1. So we do know that, take your f, and that'll be, this will be 139.5. 49 times, I'll do that one for you. 49 times, oops, sorry. 49 times 119.5. I've come out with 58, 56, 58, 56, and let's see, where is my other one? These two numbers are too big. 4 times 60 is going to be 240. And let's go ahead and do these two. That's going to be I think I just did, yeah, I did. I just did it backwards. You're supposed to square x. You're supposed to square these numbers, which are going to be big. So these are not correct. And what I'll do is I'll go to another page and we'll redo it. I'll redo so here we go. Let me go to the next page and redraw, but I'm not going to use the classes. I'm just going to do f times x. So f is 2, 33, 35, 7, and 1. And x is our midpoint. I'm just going to use 60, 70, 80, 90, and 100. And that's our midpoints. And something's not right there because 50 plus, that'd be 59, then 79, then 99, that's right, I'm sorry, then 120, this should be 120, and this should be 140. Okay, so f times x, we did f times x, and that's going to give us 119, 103, 2782. No, that's not right. It's not right at all. Let's check that one because I don't think that's right. 33 times 70. 33 times 70. 2310. I don't know where that number came from. 2310. Maybe I was 2310. That's going to throw off our. I knew there was something wrong with that number. That 51. There it is, right there. So we might have to add this up again. 2782, and then 7 times 119.5. That's 837, and 140. Let me add those up because I didn't think that number was right. 51. I didn't think that was right. 119 plus 2310 plus 2782 plus 837 plus 140, and that's going to be 6188. And then I'm going to divide that by 78. That looks a whole lot better. X bar of the standard of a frequency distribution is around 80. And I told you it looked like it should be right in here. I told you that before. So I had that. So my bad. I'm sorry about that. This number right here was incorrect. So anyway, let's move on. I'm going to do another one of these problems for you because I've messed up a couple of times and I don't want to mess up the video, so that's why I'm going ahead and doing it. X squared, we need a column of x squared, and that's going to be 3600, 4900, 6400, and I don't know what 120 is, so 120 quantity squared, that's 14400, and 140 quantity squared is 19600. Okay, and we need a f times x squared, and that's going to be f, that's this number, times this number, which is 7200. 33 times 4900 is 161,700. 35 times 6400 is 224,000. And 14,4 times 7, 100,800, and 196 would be times 1 is 196, and add all of those up, and that's going to be a lot. Plus 100, 800, plus 224, plus 161, plus 7200 equals, that's 513 times 300, or 513 300, so 513 300. And we also need this f times x quantity squared because of our formula. Hold on just a second, I lost it. There it is. Okay, there's f times x squared. The summation of that is that number right there, times the summation of f times x quantity squared. So that would be this number right here, quantity squared. So I'm just going to write this out for you. So the square root of n, which is 78, times f times x squared is going to be this number right here, minus f times x, which is 6188 quantity squared, over 78 times 77. And those are some big numbers, but you want this one to be bigger than this one, so because you can't take square root of a negative. And that's going to be times 78, and that's a BA number. So 40,400,000 minus 6188 quantity squared. That's going to be 38,291,344 over 78 times 77, 6,006, and that's going to be 40,400,000 037,400 minus 38,291,344, and that's going to give you 1,746,056 divided by 6,006 divided by 6,006, and there's our variance. Variance is equal to 290.71. So take the square root of the variance, and that'll give you your standard deviation. So raise that to the 0.5 power, and that gives us 17. So after we found a couple of mistakes, we've got a mean of 80 and a standard deviation of 17. So that would be a 97, and then 17 plus 97 114. 80 minus 17, 63, and minus 17 is 46. So 95% is going to fall between the score of 46 and 114. Now, it's very important that you find out how to use technology for this in your way. Some people like to do it by hand and use a calculator. Some people like to do it on Excel spreadsheets. Some people like to do it on their calculator and just not write anything down. I don't recommend that last one because you can get easily. You see how I had a couple of mistakes. Well, if I make a couple of mistakes, then you're going to make probably more than that. Now in the next video we'll do another one, and I will either use a little bit more technology, or I will make sure I don't have a mistake. I hope that helps. Even with the mistake, I hope it helps you. Okay, let's start another video here in just a minute.